AI agents are one of the biggest trends in artificial intelligence today. But the best way to understand AI agents isn't by reading documentation. It's by building one. In this video series, I'll show you how to build a simple stock analysis agent using LangGraph, Allama, and Python. We'll create an AI workflow that fetches live stock data, analyzes it using a locally running LLM, and generates an intelligent stock report. Let's start by defining the application state. We import typedict to create a structured state object that is shared across every node in our LangGraph workflow. Next, we import finance to retrieve live stock market data, init_chat_model to connect with our local Allama language model, and the core LangGraph components needed to build the workflow. Here, we define a class called stockState. This state acts as the central data container for our graph. It contains three fields. Ticker, which stores the stock symbol provided by the user stock_data, which hold the retrieved market information, such as price and volume.analysis, which stores the AI-generated stock analysis. As the workflow executes, each node reads from and updates this shared state, making it easy to pass information between different steps of the AI agent. Next, we create our first LangGraph node called get_stock_price. This node receives the shared state and extracts the stock ticker entered by the user. Using the finance library, it connects to Yahoo Finance and retrieves 1 month of historical trading data. If no data is available for the given ticker, the application raises an error to prevent the workflow from continuing with invalid input. Otherwise, it selects the most recent trading record and extracts key market information, including the opening price, closing price, days high and low, trading volume, and trading date. Finally, this information is returned as stock_data, updating the shared state for the next node in the workflow. After defining the data retrieval node, we initialize our large language model using init_chat_model. In this example, we're running the local Llama 3.1:8b model through Allama, allowing the entire stock analysis workflow to run locally without relying on cloud-based AI services. Now, let's move to the second node in our LangGraph workflow, Analyze. This node receives the stock_data output generated by the previous node from the shared state. Using this information, we build a detailed prompt for our large language model. The prompt includes key market data such as a ticker symbol, trading date, opening price, highest and lowest prices, closing price, and trading volume. We then instruct the model to generate a comprehensive stock analysis, including a price summary, trading activity, bullish and bearish signals, potential risks, and both short-term and long-term outlooks. To ensure responsible AI usage, we also instruct the model not to provide financial advice. The prompt is sent to our local Llama 3.1 model running on Allama. Finally, the generated response is stored in the shared state as analysis, making it available as the final output of our LangGraph workflow. Now it's time to build our LangGraph workflow. We begin by creating a state graph using the stock state we defined earlier. Next, we register our two nodes. The first node, fetch_stock, retrieves the latest stock market data. The second node, Analyze, uses the retrieved data to generate an AI-powered stock analysis. After adding the nodes, we define the execution flow using edges. The workflow starts at the start node, moves to fetch_stock, then passes the updated state to the Analyze node, and finally reaches the Yendi node. Once the graph is defined, we compile it into an executable workflow. This compiled graph is our AI agent, ready to process stock symbols, retrieve live market data, and generate intelligent analysis through a structured, stateful workflow. Finally, we execute our LangGraph workflow. Using the invoke method, we provide the input state with a stock ticker, in this case, USE. LangGraph automatically executes each node in sequence. It first retrieves the latest stock market data, then passes that information to the AI model for analysis. Once the workflow completes, the final result contains the AI-generated stock analysis. We simply print the analysis to the console. With just a few lines of code, we build a complete AI workflow that combines live financial data, a local Llama model running on Allama, and LangGraph's stateful orchestration to produce an intelligent stock analysis.